Okay, let's talk about functions. We are on chapter 2, section 2.3, and we are about to start working with functions here. So we'll just start off by going over some of the basic concepts here. It says a function is a mathematical relationship that maps each value of a set of inputs to a single output. The notation f of x is used to represent a function of x. So just before we get into it, a question that you might have, you are introduced to functions in GCSEs. So a question you might have that may have gone unanswered is why do we introduce this new notation f of x? We have a way of writing, hello Nishat, welcome. We have a way of writing equations already. You know, we can write y equals something. Why do we introduce this new f of x? And I'll talk about that in a minute. I'll give a couple of reasons. But firstly, let's kind of define what a function is. So a function is the set of possible inputs for a function. The set of possible inputs for a function is called the domain. The set of possible outputs of a function is called the range. This diagram shows how the function f of x equals x squared maps 5 values in its domain to the values in the range. The roots of a function are the values of x for which f of x equals 0. So possibly a new word or new terminology there that you haven't seen before, roots. So a root is where f of x equals 0. So why do we introduce this new notation? The first reason is that, well, let's think of an example like y equals x squared plus 3. If we're using function notation, we would say f of x equals x squared plus 3. Now this gives us a way of talking about this operation x squared plus 3 in terms of the input. So you'll notice here, if I say y, I can't do anything to that input. I just have y. But if I say f of x, I can change the input. So I can say then, well, what if we want f of x plus 2? So it actually, although it seems like we're adding complications, it actually makes our lives easier down the road by allowing us to write things like f of x plus 2. That means this is the same function, but we've just changed the input from x to x plus 2. The second thing is I've forgotten what I was going to say now. Oh yeah, the second thing is that by calling something a function, it separates it from different types of operations that are not functions. Now you'll see in a minute we can define a function as an operation that has a one-to-one relationship between the domain and the range. So you notice here, for every value in the domain, there's one output. Or it can even be one to many, so there can be 2 or more outputs for every input, but we cannot go the other way. So a function will not have many inputs for a number of outputs. So we'll talk about that in a minute, but that's another reason why we use this notation f of x, because it separates it from operations which are not functions. So the two reasons there were it makes the notation easier as you get further into the A-level curriculum, the A-level content. It makes the notation easier, and also we care about whether something is a function or not, and you'll see what that is when you get into things like calculus. You want to know if something's a function or not, and I'll elaborate on those reasons as we get into this chapter. Hello, I don't know how to say that name, sorry. I'm wondering whether you will teach us vectors. Yeah, so vectors do come up later on. Hello, Right Tree. Oh, thanks for thanks for picking that up. Okay. All right. So far, all we've said is the set of possible inputs is called the domain, the set of possible outputs is the range, and the roots of a function are the values of x for which f of x equals 0. Okay. Here is an example of using functions or finding the values of functions. Sorry, so the function f and g are given by f of x equals 2x take 10 and g of x equals x squared take 9, where x is in the real numbers. It's interesting that we haven't talked about this type of notation yet in this textbook. Perhaps they're expecting you to know that from GCSEs, possibly. But this means the real numbers. So pretty much all of the numbers we usually work with. Part A says find the values of f of x and g of 10. Okay, so we know how to do this from GCSEs. We input 5 here. So 2 times 5 take 10. That's 10 take 10, that's 0. G of 10 is 10 squared take 9, so 100 take 9, which is 91. And there's a note here, if the input of a function x can be any real number, the domain can be written as x. Oh, so it tells you here what this means. X is a real number. This symbol means is a member of, and the symbol R represents the real numbers. Oh, so you're from Hong Kong. Cool. Awesome. Thanks for joining in. Vectors is really difficult. Yeah, true. It's a different type of it's a different type of object, I guess you could call it, than other sort of geometrical algebraic objects that you usually use. Okay, so that was one example, just finding the values of certain functions, and even right here we're seeing the use of this notation. We can say f of 5. It's much more efficient to say find the values of f of 5 than to write this equation out and say so what is the value of this expression when we input 5. It's much easier to say f of 5. Okay, the next example, the function f is defined as f of x equals x squared plus 6x take 5. Write f of x in the form x plus p all squared plus q. Hopefully that's ringing some bells. If you did the last chapter, you'll notice that is what we call completing the square. So we're going to be using completing the square in this. Part B says hence or otherwise find the roots of f of x, leaving your answers in third form. Remember, the roots of f of x is when f of x equals 0. So this is just like we were doing with the quadratic equations. We're going to let this equal to 0 and then solve it just as we were in the previous chapter, but now we're just introducing some new notation. That's all that's happening here. And part C says write down the minimum values of f of x and state the value of x for which it occurs. So there'll be certain situations where you have a minimum value. So for example, in this one, because we write it as x plus 3 all squared equal to 14, this expression, x plus 3 all squared, remember something squared cannot be less than 0, right? Even if it's a negative in there, once we square it, it must be positive. So it goes into more detail. It says, we start off with this, we say x plus 3 all squared is greater than or equal to 0, because the square value must be greater than or equal to 0. So the minimum value of f of x is negative 14. Because if f of x plus 3 all squared is greater than 0, x plus 3 all squared take 14 must be greater than negative 14. Okay, and then find the roots of the function f of x equals x to the power 6 plus 7x cubed take 8. We did examples like this in the last section of this chapter. Is still a function. Is still a function that we can write in quadratic form by writing x to the power 6 as x cubed squared, and then this we can factorize this just as we would a quadratic. Set it equal to 0 and then find the roots that way. Okay. Hello Disha. On to exercise 2E then. Some practice with functions. So here we're given the functions and we just have to find the inputs, find the values of certain inputs. So let's do C, D, and E. So 1A. Actually, for these, it's good practice to write the functions down. So f of x equals 5x plus 3. G of x equals x squared take 2. And h of x equals the square root of x plus 1. So C asks for h of 8, plug 8 into this function, we get the square root of 8 plus 1, which is the square root of 9, which is 3. Now, I'm pretty confident in saying, yeah, that must be positive because it's just the square root of 9. It's not. It would have to specify positive or negative out the front here to give positive or negative 3 as the answer. So I'm fairly confident that's just a positive 3. D f of 1.5. So input 1.5 into this function. So remember that's 5x plus 3. You're late. No worries. We're just talking about functions and why we have this f of x notation, why we use it. So inputting 1.5 into f of x plus 3, I might write that as a fraction. So 1.5 is 3 on 2 plus 3. And then I can write this as 15. Actually, no, let's leave it as a decimal. Plus 3. So 5 times 1.5 is 5 plus 2.5, so 7.5 plus 3, and then that's 10.5. And G, hopefully getting the idea now, we're just inputting certain numbers into the function. Again, this is something you do in GCSEs. Inputting square root of 2 into x squared take 2. Well, what would happen if we square the square root of 2? We're just left with 2. So this is 2 take 2, this is 0. So then what could you say about the square root of 2 in terms of this function? You could say that it's a root of that function, because remember the roots are when the function equals 0. Okay, so that's enough of that. I'll leave the rest for you to do later if you like, or if you're watching this later, you can do them now. Let's go into question 2. The function f of x is defined by f of x equals x squared take 2x. Let's write that down. Given that f of a equals 8, find two possible values for a. So this is kind of the inverse of what we're just doing. We want to set this function equal to 8 and then find a. So what we do here is we say that this expression over here, x squared take 2x equals 8, and then we can find the value of x, which will be our value of a. So this is actually going to be quadratic, right? If we subtract that 8 from the left hand side, x squared take 2x take 8 equals 0, and then factorize as we were doing previously in the last section. Think of factors of 8 that make 2. I'm thinking of 4 and 2. 4 and factors of negative 8, sorry. So if we had a negative 4 and a positive 2, that would expand out to x squared take 2x take 8. And then we have two values of x. So x either equals 4 or x equals negative 2. And the question said, find two possible values of a. Try not to get confused. Like here we're saying the values of x are these things. We've still found the values of a, right? This is like representing some values for x when this function equals 8. So a then can equal 4 or negative 2. Okay. So basically that involved solving for x when the function equaled 8. Again, this kind of shows the value of this notation. Previously, without f of x, you would have to write this question in a much longer way. So you'd have to say y equals x squared take 2x, and then find the value of x when y equals 8. Okay, so it's not that much more efficient, but I'm just trying to point out some little reasons why we're using this notation. Question 3. Oops. Question 3. Find all the roots of the following functions. So let's just do a and b here. Remember, a root is when that function equals 0. So f of x equals 10 take 15x. Let f of x equal 0. So you could, well, let's see how they do it. Yeah, so they start off with that statement, f of x equals 0. So f of x equals 0. I usually say let f of x equals 0, but I guess you can just say f of x equals 0. That's fine. Who really cares? And then therefore 10 take 15x equals 0. And then solve for x. So subtract 10, divide by negative 15, we'd have x equal to 10 on 15. And then simplify, so the common factor there is 5. This is 2 on 3. So substitute 2 on 3 into here, we would get 0. That was part A. Part B, we have g of x equal to x plus 9 multiplied by x take 2. again, let that function equal 0. So we have these two brackets equal to 0. Year 12 in Hong Kong means S6. I'm not sure what S6 is. Sorry. So expanding these out, we get x squared, take 2x plus 9x, negative 2 times 9 is negative 18, and then x squared plus 7x, take 18, and then we can try to factorize. Are there factors of 18 that make 7? I can think of 9 and 2. Oops, that's meant to be an x squared. So then we need a positive 7, so we can say positive 9 and negative 2 equals 0. So then x equals negative 9 or x equals positive 2. Okay, so they are the roots of that function when g of x equals 0. Again, just to kind of make a connection as to what we were doing before. Before we were saying y equals, or even we were just writing the quadratic. We were just writing x squared take 2x plus 9. Sorry. Last chapter, all we were doing was x squared plus 7x take 18 equals 0 and solving that. Now we're just introducing some extra notation. That's all that's happening here. The same, we're still doing effectively the same stuff. Okay, alright, so let's go ahead and just check we're doing these ones correctly. So if you've done any of the other questions, make sure you check them. So this is 2e. Really, I'm up to 2e already. That's pretty good. (2019) AS papers. So I'm planning on doing those after I finish going through these, all of this, as kind of a summary, if you like. If you need it sooner, perhaps I could try to do that before I finish these, but that was my plan at least. Okay, so 2e c was 3, 2d 10.5, and e was 0. 2 was 4 and negative 2. 3 was 2/3, and 2 and negative 9. Okay, so back to where we're at. Ooh, lots of questions here. Okay, so this looks like it's going to be completing the square down here. But question 4 says the functions p and q are given by p of x equal to x squared take 3x and q of x equal to 2x take 6. Find the two values of x for which p of x equals q of x. For this, we can set those two expressions equal to each other. Yeah, sure. So just send me an email and I'll get back to you after this. Okay, so as I was saying, let's create an equation out of these two expressions. So x squared take 3x equals 2x take 6. And then solve this as you normally would solve an equation. So we want we want to combine like terms and then have everything on the left hand side. This will be x squared negative 3x take 2x is negative 5x plus 6 equals 0. So writing that as a quadratic equal to 0, that allows me to factorize. So the factors of 6 that make 5, 3 and 2, and they need to both be negatives to make negative 5. Then my solutions are x equals 3 or x equals 2. Okay. Here we have a cubic. And f of x equals 2x cubed plus 30x, and g of x equals 17x squared. Find the three values of x which f of x equals g of x. We worked with expressions like these in the first chapter. Actually, we talked about factorizing expressions with a cubed variable. So this is kind of referencing what we did earlier. So firstly, let's set these two expressions equal to each other. So 2x cubed plus 30x equals 17x squared. And then bring everything over to the left hand side. So 2x cubed take 17x squared plus 30x equals 0. And then what we were doing was firstly factorize the x out. So we've got x times 2x squared take 17x plus 30. And then we factorize this quadratic. And remember, we pointed out that at this point it's important not to divide through by x because you eliminate one of the values, which is x equals 0. So do not divide through by x at this step, rather factorize the x out as we're doing. And then let's see if we can factorize this. So factors of 30 and 2, that makes 17. Well, the only factors of 2 are 2 and 1, so we can write those in straight away. So 2x and x. And then what if we had 15 and 2? That's not going to work. So maybe 3 and 10. So if we multiply 2 by 10 and then subtract, so that's a negative 20 and plus 3, that will make negative 17. But then we have a positive 30, so that actually does not work because we need a negative 30. So other factors of 30. So let's think of the factors of 30. 1 and 30, that's not going to work. 2 and 15, pretty sure that doesn't work. 3 and 10, already tried that one. 4 doesn't go. Oh, 5 and 6 maybe. So if we did 2 times 6 and then 5, that's going to work. So we're going to use 5 and 6 here. So 2 times negative 6 is negative 12. Take 5 is negative 17. Okay. It's always nice when you can factorize. And then our solutions are either x equals 0, 2x take 5 equals 0, so therefore x would equal 5 on 2, or x equal to 6. That's our three values for x. Okay. So they only have one problem like this. I wish they had a few more, but that's fine. So question 6 says a function f is defined by f of x equal to x squared take 2x plus 2. Write f of x in the form x plus p all squared plus q, where p and q are constants to be found. Remember, this is completing the square. We went through this yesterday. Let's go ahead and see if we can do this one by completing the square. Firstly, remember we halve the coefficient of x, so we do x take 1 all squared. Half of negative 2 is negative 1. Then we subtract that term squared. So 1 squared, or sorry, negative 1 squared is just 1. And we have that positive 2 on the end. And then let's simplify. So negative 1 plus 2 is 1. So we've got x take 1 all squared plus 1. And if you're ever unsure as to whether you've done it correctly, just expand it out again and make sure you end up with what you started with. So if we expanded this out, we'd get x squared take 2x plus 1 plus 1. And you can see that's x squared take 2x plus 2. So there we have it in the form x plus p all squared plus q. So here p is equal to negative 1, q is equal to 1. A2 papers, I've gone through the 2019 A2 papers on my channel. If you go to playlists, it's called A-Level 2019 papers, I believe. If you want to check those out. Maximo says, "Hallo, hier ist mein Warten." I'm not sure what that means. Here is my something. Okay. So that was part A of 6. Part B says explain why f of x explain why f of x is greater than 0 for all values of x and find the minimum value of f of x. Okay, so here we start with this squared term. We know that a squared term must be greater than 0. So then, greater than or equal to 0. So then, x take 1 squared plus 1, which was f of x. Well, we add 1 to both sides, so this must be greater than 1. Explain why f of x is greater than 0. Well, we've just shown, well, this is f of x here, right? That was another way of writing f of x. So f of x must be greater than or equal to 1. And then the minimum value clearly is 1. So we could just finish off with the minimum value equals 1. But they've written only greater than. Why could this not be 0? Oh, right. Yeah, okay. That's weird. No. So what I was going to say is if x equals 1, this is equal to 0. But yeah, so that's equal to 0, but that's fine, isn't it? I'm confused as to why this cannot be equal to 1. So if x equals 1, this is 0, then f of x equals 1. Oh, sorry. Yeah. I was getting confused. This says f of x greater than 0. We've said f of x greater than or equal to 1, and then the minimum value is 1. Everything's fine. No problems. Umar says, I started the chapter on differentiation derivatives and it's been going well so far. Thanks for the suggestion. Great. Awesome. Well done. Keep it up. Okay, so there were no problems there. I'm not sure why I was getting confused. All right, on to question 7. Find all real roots of the following functions. Okay, these are all still going to be quadratics. You can see that quadratics because the first term is always the square of the second term. So here, even this one, 2x to the power of 2 on 3. X to the power of 2 on 3 is the square of x to the power of a third. So even though they have different powers, even x and the square root of x, x is the square of the square root of x. So all of these are still quadratics. So you could do these the same way as we have previously been finding the roots of quadratics. So I'll just do one of these and I'll leave the rest for you if you'd like to have a go at those. F of x equals x to the power 6 plus 9x cubed plus 8. Find the real roots. That's saying when f of x equals 0, that's the roots. That's I mean, if you want to picture this, you can think of a quadratic as a parabola, whatever it would look like. The roots are where the parabola cuts the x-axis, where f of x or y equals 0. Remember, usually we would say that y equals f of x. So where f of x equals 0, they are our roots. And I'm not actually sure why they're called roots. Maybe we should look that up. Why are they called roots? Why do we call them roots in maths? So just reading here, why do we call them roots? So they are roots of a plant. Later it was generalized to mean the origins or the beginning of something, whether it's physical or mental. The origin number. Okay. So, okay, that's a fairly common sense connection. So we call them roots because it's like the origin number, where the, and we think of 0 usually as the origin. So it's where the function equals 0. Fair enough. Okay. Okay, so what we're doing, we're saying when f of x equals 0, this expression equals 0. And then we want to write it in quadratic form, so we can write x to the power 6 as x cubed squared. Remember your index laws. X cubed just as x cubed. And then plus 8. You can also replace x cubed with another variable if you find that easier. So you could say like z equals x cubed, and then you can write this as z squared plus 9z plus 8, and then you can see it looks like a quadratic, but you don't have to do that if you don't want to. For me, I consider it extra work, but if you find that easier, absolutely go ahead. So now we have a squared term plus 9, lots of that thing, plus 8. Can we factorize this? Let's see, are there factors of 8 that make 9? Well, I can think of 8 and 1. So this would be x cubed plus 8 and x cubed plus 1. This would expand out to x to the power of 6 plus 9x cubed plus 8. Okay. And then, well, we still have to find the values of x, so we say x cubed plus 8 equals 0, or x cubed plus 1 equals 0, and then x cubed equals negative 8, or x cubed equals negative 1. Therefore, x equals negative 2, and x equals negative 1. Okay. So that's how we're approaching those ones. I'll leave the rest for you to do if you'd like to do those. The last question says the function f is defined as f of x equals 3 to the power of 2x take 28 multiplied by 3 to the power of x plus 27. Write f of x in the form 3x take a multiplied by 3x take b, where a and b are real constants, hence find the two roots of f of x. And here it says consider f of x as a function of a function. I might leave that one for you. See if you can figure out how to solve that. 3 to the power x take a. How would you find the value of 3? My guess is it would become clear once you find the values of a and b, and then hopefully you can figure it out from there. Okay, so I'm going to move on. Before I do, let's check these ones just to make sure we're not making any mistakes. So 2E question 4 was 3 and 2. 5, 0, 2.5 and 6. P negative 1, Q 1. So the minimum value is 1. And 7a was negative 2 and negative 1. Okay. Alright, so that was pretty much revision of functions for GCSEs. That's actually, I mean, we don't go into too much detail on functions in GCSEs, so that's definitely worth revising. Okay, making good progress here. We're on to 2.4. Quadratic graphs. So graphing quadratic functions. Okay. I feel like playing some music. Let's see. YouTube friendly music, of course. That won't get a copyright strike and have the video blocked. and deleted. Alright, quadratic graphs. Have a sip of coffee. When f of x equals ax squared plus bx plus c, the graph of y equals f of x has a curved shape called a parabola. You can sketch a quadratic graph by identifying key features. The coefficient of x squared determines the overall shape of the graph. When a is positive, the parabola will have this shape. When a is negative, the parabola will have this shape. So I like to think of that as a positive quadratic has a smiley face and a negative quadratic has a frowny face. Positive and negative, right? So here we have a nice diagram. It says 1, the graph crosses the y-axis when x equals 0. That's the y-intercept. The y-coordinate is equal to c. You know this already, hopefully, that if you have a quadratic like this, if x equals 0, those terms there cancel out. So we're just left with c. So the y-intercept is c. The graph crosses the x-axis when y equals 0. The x-coordinates are roots of the function f of x. So this is kind of the geometric understanding of what we've just been doing algebraically. We've been finding these roots, and these are what we call the x-intercepts, where the graph crosses the x-axis. 3. The quadratic graphs have one turning point. This can be a minimum or maximum. Since a parabola is symmetrical, the turning point and line of symmetry are halfway between the two roots. Okay, so either a minimum or maximum. If the graph is a negative quadratic, it will obviously be a maximum, and that is halfway between the two x-intercepts, or the two roots. Okay, so you can find the coordinates of the turning point of quadratic by completing the square. So if f of x equals a, bracket x plus p all squared plus q, the graph of y equals f of x has a turning point at negative pq. This is what we sometimes call the vertex form of a quadratic, because it gives you that vertex straight away. If you have a quadratic in the form in this form where you've completed the square, you get the quadratic. And it says here the graph of y equals ax plus p all squared plus q is a translation of the graph of y equals ax by negative pq. If you watch my video on graph translations, you will I kind of go through that in more detail in that video. Okay, some examples here. Sketch the graph of y equals x squared, take 5x plus 4 and find the coordinates of its turning point. Well, firstly we know what it should look like. Find the y-intercept. Find the y-intercept and the x-intercepts, or the roots, and then the vertex. You can either do that by completing the square or finding the midpoint between the two roots, and then sketch a graph. I should have got some graph paper for this, but I don't have any on this program at the moment, so we'll see how we go without the graph paper. So let's get stuck into a few. So another example here. So the previous example said find the coordinates of the turning point. This one says find the coordinates of the turning point, write down the equation of its line of symmetry. So the line of symmetry is basically the x value of the turning point, right? That's where the graph is symmetrical, around that line going through the vertex, the minimum or maximum. Also, this example is interesting because it's an example where we have no real solution, so no root. So the graph does not cut the x-axis at all. So you're going to have a negative number in that quadratic formula, which is something we haven't talked about yet, but it is something we talk about briefly in GCSEs. And then you find the maximum and then the line of symmetry. Okie dokie. Let's have a go at a few. Oh, this is just a short section. That's fine. I guess you don't need a lot of practice on this. It's not, I guess it's not a big topic in A-levels. But anyways, so we're on to 2F. And I'm going to be attempting to sketch some graphs on here. So 1 says sketch the graphs of the following equations. For each graph, show the coordinates of the points where the graph crosses the coordinate axis. Sorry, I need to read that again. For each graph, show the coordinates of the points where the graph crosses the coordinate axes. So that's the y and x intercepts, and write down the coordinate of the turning point and the equation of the line of symmetry. Okie dokie, so I might do the first 4 and then leave the rest. So A, y equals x squared, take 6x plus 8. Firstly, the y-intercept, that's always the easiest one. Y-intercept, this is always the constant on the end, right? If x equals 0, these cancel out. So I'll just make a note now, but I won't write this in the other ones. The y-intercept is when x equals 0. So so therefore y-intercept equals 0, 8. X value is 0, the y value is positive 8. I'll just check how they were writing that. Oh, so they say the graph crosses the y-axis at 0, -3. I generally just write y-intercept. I think that's fine as well. Then we need the x-intercepts. That involves finding the roots or where this equals 0. So x-intercept when y equals 0. So this is when x squared takes 6x plus 8 equals 0. And then let's try to solve this quadratic as we have been doing all along. So are there factors of 8 that make 6, -6? I'm thinking of 4 and 2. So I can factorize this as -4, -2. And then x, we could even say, let's say therefore the x-intercepts are 4, 0, and the x-intercepts are 4, 0, and 2, 0, right? Because the solutions for x here are 4 and 2, so these are my x-intercepts. Then we need the turning point. Now, because this example makes it fairly easy to find the midpoint, I'm just going to say the turning point is the midpoint of these. But just keep in mind you can also use completing the square for this. So turning point is the midpoint of 4, 0 and 2, 0. I guess really the only time you need to use completing the square to find the turning point is when you don't have these x-intercepts, when the equation does not have any solutions. So the midpoint between 2 and 4 is 3. Midpoint equals 3, 0. Sorry. That's the x value. So x value of the midpoint equals 3, and then you need to find the y value. So when x equals 3, y equals 3 squared, take 18 plus 8, so that's 9, take 18 plus 8. I'm just plugging 3 into this expression up here. And this is negative 9 plus 8, that's negative 1. So the turning point is, therefore turning point equals 3, negative 1. Okay, I just want to see they use completing the square. Yes, so when they used, they said alternatively the minimum occurs when x is halfway between 1 and 4. So you could write all that, or I mean, I generally encourage you to use as little writing as possible. It's just more efficient. So yeah, you can summarize that in your own way. Okay, so the turning point is 3, negative 1, and then therefore the equation of the line of symmetry is x equals 3. That's a vertical line at 3 on the x-axis. So they take quite a bit of time. I might just... Oh, and then I need to sketch it. So I haven't even finished yet. Okay. Actually, let's draw it like this. So this is the y-axis, this is the x-axis. So my x-intercepts were 2 and 4, and my y-intercept was 8. Okay, so my scales are going to be different there, but that's fine. This can be 2, this can be 4. And then I'll go up by 2s on the y-axis. So this is 4, this is 8. And my minimum was 3, negative 1. Okay, so I should have graph paper for this. Unfortunately, I didn't get that organized on this program yet, but here we go. So the y-intercept was 8, so I'm going to go down from 8 to the first x-intercept, and then down to the minimum of 3, -1, and then up to the other x-intercept, and then over here somewhere. Okay, good enough. So this was y equal to x squared take 6x plus 8. And the minimum was 3, -1. This root was 4, 0. This one was 2, 0. And the y-intercept was 0, 8. Okay, I might just do one of those because I'm not too good at sketching on this. This looks terrible. And it's quite time consuming, but hopefully that gives you the idea. Actually, I should do one more that does not have any real roots. Let's see. One that we cannot get solutions for x of. Maybe I? Let's see. So one more of these then. I is y equal to 4 take 7x take 2x squared. Firstly, the y-intercept. Intercept is equal to 0, 4, just that constant. The x-intercepts are when this equals 0. And I like to divide through by -1 so that I have a positive here. So that turns, both of those negatives become positives, and then I have a -4 on the end. And then let's see if we can factorize. So factors of 4 and 2, that makes 7. Oh, that is going to work, I think. So actually, so if we do 2 and 4 and then 1 and 1, can we make +7 and -4? So it would have to be +8 and -1. That does factorize. I wanted one that did not factorize actually. I wonder if there's a way of telling if something will have x-intercepts just by looking at the quadratic. Oh, I think this one, no, that's 2 and 1. What about this one? Maybe F. Factorizes to 1 and 10. That doesn't make 4 and 5 and 2. Okay, so F is not going to have any real roots. Let's do F. Y equals 2x squared plus 4x plus 10. So the y-intercept is 0, 10. The x-intercepts are when all of this equals 0. And I don't believe we can factorize this one. So facts of 10 are 10 and 1, and facts of 2 are 2 and 1. I cannot make 4 with those. Same with 5 and 2. I cannot make 4 with those either. So we could either use completing the square or the quadratic formula. It's up to you. I prefer using completing the square on examples like this. So the first thing I do is divide through by 2. Because it equals 0, I can do that. This is x squared plus 2x plus 5 equals 0. And then take the 5 from the right hand side and write this as x plus 1 all squared. Take 1 squared is just 1. This is equal to negative 5. So x plus 1 all squared is equal to negative 6. Negative 5 plus 1 is negative 4. And hopefully you notice here we have a squared expression equal to a negative. This means there are no real solutions. There are no real solutions for x. So that means there are no x-intercepts. Okay, and just want to check how they stated that. So they say, so the graph does not cross the x-axis. So that's the same thing. There are no x-intercepts. So saying either of those two things is fine. So the only other thing then that we have to find is the minimum or maximum, and we do that by completing the square. So we've already done part of that. We can just use this part to say y equals x plus 1 squared take 1 plus 5. That's what we would get here if we complete the square on it. So this simplifies to x plus 1 all squared sorry, I forgot that I divided by 2, so we cannot divide through by 2 now. We just have to use completing the square on this expression here. So if we factorize the 2 out, we have 2 multiplied by x squared plus 2x plus 5, and then we can write that expression as x plus 1 all squared take 1 plus 5 was plus 4. And then if we expand the 2 out again, we get 2 times x plus 1 all squared plus 8. So then remember the vertex was the negative of the number in the brackets, negative 1, and then the positive 8. So that was, where was that? That was written here. So if we have ax plus p all squared plus q, the turning point is negative pq. Okay, so that's my turning point. So this is, vertex is the same as turning point. And then I needed the equation of the line of symmetry. Line of symmetry. Remember, this is always just x equal to the x value of the turning point, so x equals -1. It's the line going through the line of symmetry. Oh, and that's something I forgot to draw in up here, so I needed to draw that in the graph as well, so that was here. So this was the line of symmetry at x equal to 3. Then I need to sketch this graph. So I had a y-intercept at 10, no x-intercepts, it's a positive, so it's going to be above the x-axis, and a minimum at -1, 8. Okay, so let's see how we go here. This is my x-axis. This is my y-axis. I need to go up to 10, so I'll go up by 2, 2, 4, 6, 8, 10. And across by 1s on the y-axis. So -1, -3. Okay, so again, the turning point, -1, 8, that was here. The y-intercept was 10, and the line of symmetry was at -1. So I guess we'd have another point at -2, 10, and then draw that in. Okay, so that is the graph of y equals 2x² plus 4x plus 10. This is the minimum, -1, 8. This is the y-intercept, 0, 10. And we also need a line of symmetry at -1. X equals -1. Alright, let's just go ahead and check that all of this is correct. They are quite long, aren't they? So this is 2f. I wonder, do they give the graph? They do give the graphs in the answers, that's nice. So firstly we did x² take 6x plus 8. The turning point is at 3, -1. Therefore the line of symmetry is x equal to 3. We had y-intercept 0, 8, x-intercepts of 2 and 4, and so there's your basically 5 marks for a question like this. Then we did f. So we had 0, 10 as the y-intercept, and the turning point at -1, 8, and the line of symmetry at x equals -1. Jasmina, hello? Okay, and if you had to go at any of the other ones, please make sure to check your answers here. Okay, where were we? We were up to question 2, so that's all I'm doing from part 1. I'd encourage you to have got the others. Question 2. It says, these sketches are a graph of quadratic functions of the form ax squared plus bx plus c. Find the values of a, b, and c for each functions. For each function. Do I have Instagram? No, I don't. Just YouTube at the moment. Okay, so we're doing the opposite of what we were just doing. We were given the equation and we were asked to graph the function. Now we're given the graph and we want to write the function. So I'll just do the first two. Firstly, the y-intercept is 15, so we can say y equals ax squared plus bx plus 15. Actually, there's a better way to do this. Looking at the x-intercepts, we can say that x take 3 multiplied by x take 5 is the function, right? Because remember, if we factorized something into this form, the solutions would be x equals 3 and x equals 5 for when it equals 0. So we can do the reverse of that and say if the function is equal to 0 at 3 and 5, then it must equal x take 5 and x take 3 and x take 5. So we can say f of x equals x take 3, x take 5. And I'll just give some reasoning as when f of x equals 0, x equals 3, and x equals 5. So you can reverse that to say this, and then you could expand that out. So therefore f of x equals x squared take 8x plus 15. And then you can see that if x equals 0, y equals 15. So that checks out as well because the y-intercept is 15. Okay. So for the values of a, b, and c there, a equals 1, b equals -8, and c equals 15. For b, again we can use the same logic to say f of x is the product of the factors or the roots. So if we have a root at -2, that means x plus 2 must be a factor. That would give you a solution of x equals -2 when f of x equals 0. And then x take 5 because positive 5 is a root. Will I be streaming on Sunday? No, I won't. I won't be streaming over the weekends. Sorry about that, but I should have videos. I should be posting videos on Saturday and Sunday, but no live streams. And then expand these out. So this is x squared, -5 plus 2 is -3x, take 10. Ooh, what have I done here? Oh, sorry. The other thing I forgot with this one is because it's a frowny face, because the quadratic is upside down, I need to include something. I need to include a negative because it's a negative quadratic. So then once I expand that negative out, I get I get negative x squared plus 3x plus 10. And then the y-intercept checks out. Yeah, there's a bit of a lag. I've put on low latency on the stream, but it still seems to lag quite a bit. So when I say something, it takes a while. Okay, so that are those two. Here it says check your answers by substituting values into the function. In part C, the graph passes through 0, 18, so h of 0 should be negative 18. Okay, little tip there. And then 3, let's see. 3 says the graph of y equals ax squared plus bx plus c is a minimum at 5, negative 3, and passes through 4, 0. Find the values of a, b, and c. So this is similar to these, except they give you the minimum instead of the x coordinates. So I still have, so one's going to be a GCSE video. I have paper 3 of the GCSE papers I'm doing, so that's going to be GCSEs. And then the other one might be something a little bit different. It won't be related to this or GCSEs, it'll just be something a little bit different. But next Monday will be another stream. Okay, so if we're given the minimum, let's see. I would start off by writing it as y equal to a x take 5 all squared take 3. So this is for 3. That's how I'd start off. And then to solve for a, I'd let x equal to 0. X equal to 0 gives us the, y equal to 0. X equal to 4, that gives us the, that will allow us to solve for a. So that's how I would approach this type of question. So I would say when y equals 0, x equals 4, and then plugging those values into this equation, find the value for a. So a times 4 take 5 all squared take 3 equals 0. This is negative 1 squared is 1, so a take 3 equals 0, so a equals 3. So then we have y equal to 3 times x take 5 all squared take 3. Okay, so now I want to go ahead and check those couple of problems. This was 2F again. A 1 negative 8 15. B negative 1 3 and 10. And 3. Oh. Clearly I got 3 wrong there. What did I do wrong for that one? Oh. I have to expand that out. But I don't think I'm going to get negative 30 and 72. Oh, maybe I will actually. Yeah, so all I did, so I actually have done this correctly. I just need to remember to expand it out because they wanted it in the form of ax squared plus bx plus c. So expanding this out, we get 3 times x squared take 10x plus 25 take 3. So maybe you can make definitive guides along the lines how to solve binomials, just a suggestion. Yeah, so like my other videos, I was kind of hoping in these live streams to get more participation. I know it's like the summer break and people, you know, obviously people don't want to be doing maths revision, and maybe the time is not great, but I'm hoping at some point there could be a point where there's some kind of level of participation, and that would make it more fun. That was the plan, because I was reading an article the other day about the fact that a lot of GCSE students have not had any work given to them for the last 3 months. So some students have not had any online work, have not been given any work from their schools. So I thought possibly there might be some enthusiasm to do some revision over the summer, but of course it's summer, and who wants to do maths revision? I guess the people here are going to get the real gains. Well, I hope so. The other thing is, this is what I'd be doing this is what I would be doing anyway. I just bought these textbooks. And so when I buy a new textbook, I want to work through pretty much the whole thing. So I thought, if I'm going to be doing this, why not just live stream it? And then I could have some company. So it's kind of like a study with me type of thing. So it's basically what I'd be doing anyway, but I'm just kind of live streaming it to see if anyone wants to join in. So yeah. Well, I'm glad you're enjoying it. I hope you're getting some use out of it. Nazim, hello. I'm a GCSE student, a bit interested in A-level maths. Cool. Awesome. Feel free, if you have any questions, just post them, or if you have any topics you want to talk about, we can talk about those. Okay. Alright, so that's 2.3 and 2.4. Pretty good progress today. I have to go. CKG, I'm beyond the schooling age. Cool, awesome. How, looking at the content so far, Nazim, I'm not sure how much have you seen, but what do you think so far? You say it's harder, but any opinion? Oops. Yeah, there's a lot of crossover. There's a lot of crossover in year 12. So far I'm finding this textbook is just doing a lot of revision so far. But yeah, law of sine, cosine, yes, very useful stuff from GCSEs. I'm not going to be going through this section 2.5. That's going to be on Monday. I was hoping to get through it today, but unfortunately I've run out of time. Just to summarize, today we looked at functions, we talked about functions, talked about why we introduced this new notation f of x. We said it gives us a way of identifying a function rather than just an expression, and it makes life easier down the road when you get into calculus and things like that. Using that notation makes things easier. And also, if you're doing computer science or any type of programming, you probably already know the use of functions, the value of functions. So we talked about functions, solving problems with functions. We looked at quadratic graphs, so graphing quadratic functions, finding the turning point, the x-intercepts, the y-intercept, and then graphing it, and the line of symmetry. And did a couple of problem solving questions, and the next live stream will be on the discriminant. So you're year 10, cool, getting a head start, awesome. So I'm just going to hang out for another 5 minutes if you guys have any other topics or questions you want to talk about, and then I've got to go. So if there's any other topics or maths questions you have, will there be geometry? Yeah, lots of geometry. Circles. Midpoints and perpendicular bisectors. Oh, that's just of straight lines. That's not of circles. The equation of a circle, which you've probably seen in GCSEs. The intersection of straight lines and circles. That's still GCSE stuff. Let's see. This might be new. The perpendicular bisector of a chord will go through the center of the circle. Yeah. So tangent and chord properties, that's something new that comes up in chapter 6. How does the physics section look like? You mean mechanics? So this is year 1 mechanics. So you've got modeling in mechanics, constant acceleration, forces in motion, and variable acceleration. They're such vague names, it's hard to kind of describe what these are referring to. Shape equations. So the equation of a circle. Then you've got circles and triangles. Not really sure what that's referring to. Oh, circumcircle, circumcenter. That stuff's pretty cool. You can find the center of a circle given any 3 points on the circumference. That looks like fun. What else? So that's all that I can see in this first year topic. I guess in proof you could really cover anything. I mean, there could be some geometry in proof, or you could, I mean, it's possible you could create geometric proof questions. So here's one, for example. Yeah, that's all I can kind of see in terms of like the geometry I think you're talking about. How big is the bridge between GCSE and A-level? I don't think it's that big, to be honest. So let's see. The topics that I would point out as the main ones would be the binomial expansion. This always comes up in A-level exams, the binomial expansion formula. At least in every exam, in every set of exams I've done so far, I've seen that binomial expansion formula. Trigonometric identities and equations, that's another big one. And then calculus and logarithms. So in the first year, there's like 3 or 4 major new topics. The rest is kind of like an extension of what you've already done. Just kind of like the harder level topics in GCSEs, just kind of like taking them and extending them a little bit. For example, in graph transformations, you talk about graph transformations in GCSEs, but we don't talk about stretching graphs. We talk about translating graphs, we don't talk about stretching graphs. So that's introduced in A-levels. So it's like, it's a topic you're already familiar with and you'll already learn how to do that. Then we're just adding a little bit extra. So what does it mean to stretch a graph out? How do you know how far to stretch the graph? That's something you'll learn in A levels. So I'm seeing a lot of that. It's just kind of taking a topic you're already familiar with and then extending it a little bit. So I would say the bridge is not actually that big. Awesome. That's so cool to hear. University level maths is even cooler. A lot of graph work. Yeah. Yeah, that's sort of a drag. Especially if you have to draw a lot of graphs, that kind of gets repetitive. Yeah, a lot of drawings, a lot of sketches. Alrighty. I really have to go. No, I do not teach in a grammar school. My dad is very proud of telling everyone he went to a grammar school, but I do not teach in a grammar school. Alrighty, thanks for tuning in. It's really nice to have a chat. Thank you for your company. Hopefully you got something out of that, and I will see you on Monday if you want to catch the stream on Monday. Alrighty, see you then. Bye for now.